Okay, in this lecture, we're going to be finding the left, right, and midpoint Riemann sum of 20 plus 1 over x from 2 to 9. But this time we're going to use a large value of n, and that would be 50. So we're going to do 50 subdivisions. And this time, though, we're not going to make a table and write down all 50 of these numbers. But what we're going to do here is use the summation feature of the TI-84 graphing calculator and actually have it come up with the actual solution. Okay, but as the other kind of Riemann sum problems, you still have to figure out the width, and the width is still, of course, b minus a over n, which in this case is 9 minus 2 over 50, which is 7/50ths. Okay, which means, of course, that the first term is 2, the first grid point is 2, the next grid point is 2 and 7/50ths, the next grid point is 2 and 14/50ths, the next one is 2 and 21/50ths. So there's a lot of grid points. Obviously, there's 50. Okay, well, fortunately, our graphing calculator has a really good summation feature that can do this. But of course, in order to be able to use the summation feature, you have to be able to know the general forms of the CK, the grid points, using left, right, and Riemann sums. Okay, and these you have to know. For left sum, it is CK, the grid point, is equal to A plus K minus 1 times delta X. Of course, where this comes from is the fact that in the left Riemann sum, okay, remember K always starts at 1. The left Riemann starts at A and it ends at 1 delta X less than the right endpoint. And that's why it's K minus 1 times delta X. So you start at A and you add a width every time, but then you end up at one short of the last one. Whereas the right Riemann sum starts at 1 width past the left endpoint, and it ends at the right endpoint. So that's why the right Riemann sum is A plus K delta X. Okay, the midpoint, of course, is the trickiest. The midpoint, as I actually showed in another video and I talked about in class, is that the midpoint starts at K plus delta X over 2, or A plus delta X over 2. So to rewrite it in K form, that would be K minus a half times delta X. You need to know all three of these in order to be able to do these problems. Okay. Okay, so here's how this works. So for the left Riemann, our CK is going to equal A plus K minus 1 times X. A is 2, okay? Delta X is 7/50ths. So CK is A, which is 2 plus K minus 1 times 7/50ths. And you need to simplify this by distributing and adding some like terms. And when you do this, you will get 93/50ths plus 7/50ths K is for the left. Okay. For the right, CK is equal to 2 plus K times 7/50ths. That is A plus, that is here A plus K times delta X. So when you simplify this, this is, well, it's basically what this is. This is just CK equals 2 plus 7/50ths K. Now, for the midpoint, CK is equal to A, which is 2, plus K minus a half times delta X, which is 7/50ths. And then what you do, and then again, you'll distribute here. And this one ends up being 193, CK equals 193 over 100 minus 7/50ths K. All right, now I'm going to clear this screen. So, but what we're going to do with each of these answers, what we're going to do with each of these, with this one, and this one, is we're going to plug those in to the original function for x, okay? Because that's what we have to find, FCK. And then we're going to have the calculator sum these all up, okay? So let me clear this up. So basically, remember that the Riemann sum is equal to the sum of k equals 1 to n. Well, in this case, n is going to be 50, of FCK delta x, or delta x. Or we're going to put the delta x in front and take it times the sum as k equals 1 to 50 of FCK, and then we're going to put that into the calculator. Okay, so let's do this for the left sum. So again, the left sum, the CK, is equal to 93/50ths plus 7/50ths K. And this is going to go into the equation. Okay, so FCK is equal to 20 plus 1 over 93/50ths plus 7/50ths K, because that's putting 93/50ths plus 7/50ths K in for x into our function 20 plus 1 over 93/50ths, 1 over x. Okay, so therefore the sum is going to equal to, and then what we're going to do is we're going to use this here. So the sum is going to equal to delta x, which is 7/50ths, times the sum from k. Actually, I think we're going to use x because it's just easier on the calculator instead of using k's to use x. So x equals 1 to 50 of this function, which is 20 plus 1 over 93/50ths plus 7/50ths K. And you don't have to properize this fraction. It's easy. It's 50 over 93 plus 7K. That's actually pretty easy to do. But I'm just showing you that you don't have to. You could put this in exactly, you could put this exactly in the way it looks here. So this is what we're actually going to put in. So let me bring up the calculator again. Okay, I got to turn it on. So turn on the calculator, and then we're going to go to math 0 for the summation. X equals 1 to 50 of, oh, I forgot something. Let me clear this. I forgot to multiply by the width because we're going to do 7/50ths. So I'll do the fractions. So 7/50ths. You could multiply it at the end too, it doesn't matter, times, okay, here we go. Math 0, the summation of x equals 1, up arrow, to 50, okay, of 20 plus, and then I'm going to do alpha y equals and select the fraction again, 1 over alpha y equals fraction, 93, down arrow, 50ths, plus fraction 7/50ths, and then an x, like so. Let this wait. There it is, 141.532. So this equals 141.532. That's the left sum. Okay. Now the right sum, the sum is equal to, again, I apologize for my handwriting, 7/50ths times the sum of x again equals 1 to 50. Now remember the right sum I had in the previous page, the right sum is 2 plus 7/50ths K. So this is going to be 20 plus 1 over 2 plus 7/50ths K. So now, to simplify this a little bit, so I don't have to type it all in, because most of it's the same, I just arrow up and highlight it and hit enter. Okay, and then, so since this is 2, I'm just really trying to save time. Since this is just 2 plus 7/50ths K, I'm just going to make that 100 on top, because that's the same as 2 plus 7/50ths K. Everything else is the exact same. I let that run, and I get 141.477. And then the midpoint, oh, I apologize for my handwriting. It's getting really bad. Sum is equal to 7/50ths times the sum of x equals 1 to 50th of 20 plus 1 over, now remember the midpoint was 193 over 100, 193 over 100 minus 7/50ths k. And then this is going to be, so again, I go up to here, hit enter, and then this is now 193, so we'll just overstrike that. And that should be good to go. $141.023. Wait a minute. This is actually wrong because I noticed this is not between the other two because I did 193 over 50, not 193 over 100. I wonder if any of you watching this video caught that, but of course couldn't say anything because you're watching me making a video, but I caught it now. So there that is, because the midpoint's got to be between the left and right, and that's how I knew it was wrong because my midpoint was not between. 141.504, that looks like a lot better. So 141.504. Okay, so you could make a claim then that the actual area is probably very close to 141.5. And so again, you could even shrink this up even more by using even more rectangles. Okay, now in the next video, I show you how we can find the actual sum using summation formulas and taking the limit as n goes to infinity. And if you take the limit as n goes to infinity, that actually gets you the actual sum. All right, thank you very much.